Hello and welcome back to Amplified 208. Today we have ourselves a Onkyo M 5060R Integra. This amplifier here, I did a complete recap on it. Straightened all the chassis. This thing was dropped at one time. The previous owner, the guy that owns this now, he wanted it recapped and put all new LEDs in the front. You want a nice green glow. A lot of the indicator lamps here, power light and everything did work, but the speakers on and off 1 and 2 didn't work, and the indicator for on and off, that's on. Chassis was really bent. Meters, a lot of the lights didn't work. I'll probably do a little bit of a montage with part of the video. I hope you guys kind of stick through the montage of it, and then I'll come back and then kind of explain a couple little more things, but I'll put that in the video now. You can have a look at it. Alright, so hopefully you stuck through that video there. And right now what I'm doing is I bench test this thing the other day, probably for a good, well, all day actually. Put it under various conditions. I recommend on this thing, when it says to come setting the meters in the service manual, don't run this thing without a load. It doesn't like it. This here had all brand new output transistors put in it. It had a lot of the 2SC 1815s. They were all replaced. The output transistors, like I said, replaced with TT's 5200s, the TTC 5200s, and TTA 1943s, I do believe. Far superior. Right now, I'm just triple checking I should say quadruple checking the bias. I've been non-stop checking the bias on this. Here you can see it's around 13, 14 millivolts. Now it's 14. Kind of jumps up a little bit and a little bit down. You breathe on this thing, it'll change, which is good. This thing originally, when I got it, it was idling at over 90 watts just by plugged in, no audio signal, no nothing. And now we're sitting at 66.4, 66.6. That's where it sits, between 119, 120 volts AC. I'll show you some pictures down in the recap. You see all the Nichicon and Worth capacitors. It's all been replaced. Straightened up all the other resistors. I put in new dropping resistors for the regulator, voltage regulation here and there. It's for all this. All new Zener diodes for voltage references. All very tight tolerance from DigiKey. The new Zeners. All new diodes. 4148s. And the same with the thermal compensation diodes on the heatsink. They were replaced with a pair of the 4148s. A little TP style package, and brought up all the solder joints on the board, and all this completely came apart. I put all new banana plug jacks in the back of it, got rid of the other ones. I didn't want to mod the original boards, so I just made up my new boards and then bolted these to the back. Added the IEC connector, painted the chassis. The chassis was just, had some rust on it, and it was all bent. As you're going to see, you've probably seen in the video, it was dropped at one time. But now it looks really good. The LEDs all converted, like I said. The test points on this for the bias, you'll see it. There's a current ID pin. It says IID on it, and the other one's the voltage of the center tap. You measure across there with your voltmeter, the digital voltmeter, and you will get your 14 millivolts. It's definitely, you have to let this amplifier warm up. It takes quite a few minutes to warm up before it's even somewhat wants to play nice. Don't run these on a 6 ohm load. They don't like it either. It seems to be very picky on the 8 ohm, and the meters are zeroed out, as you can see, straight on 0 and 0. And you have to do like a 2-step process for that. First, you got to zero them out when the amplifier is not powered up, and then once you power it up and everything's warm and stable, you want to let everything warm up to equilibrium. And then there's offset adjustment here, And the other offset adjustment, I'm pretty sure it's this one. And then these here are for your actual nulling it out, for your actual peak levels to adjust it correctly. And then these meters are bang on with the 8 ohm load. Yeah, if you try to run this thing and do the meter adjustment according to the service manual, this thing will go into protect mode. Because it says to go up to 10.2 volts on a meter, no load, and then you're supposed to set this in your 0.1 time up to the 0 dB mark. Well, unfortunately, when you do that, you'll get to about, I don't know, 5-ish, even before the 0 dB, and then it'll flip over to the protect. Yeah, so don't do that. I didn't like it. I spent probably yesterday, I don't know, 2-3 hours figuring out why this thing was going into protect mode, which was weird because it shouldn't have. And once I, you know, didn't exactly, I went kind of made my own procedure up, and then I had no problem. So yeah, you just make sure it's loaded with a good dummy load, an 8 ohm load. Don't load it down to any more than 8 ohms. Don't go to 4. They don't like it, especially this model for some reason. You would think it would take a 4 ohm load because a lot of speakers, my test speakers are 6 ohm, and when I start driving it hard, it'll kick them out. It'll kick into protection. It doesn't like it. You throw in an 8 ohm load, I can drive this thing all the way to 100 watts, no issue. My dummy load is only good for 100 watts, so I can't exactly bring it to the 100 and I think this is 130 RMS, which I don't really push this too hard on the dummy load for that reason. As you can see, this thing tracks very nicely. There's 14 millivolts, what the service manual requires. And the other one, you'll see it jumps up about 14.4, 14.5. It'll drop down to 13.8, 13.9, and it just kind of goes around there. It'll just stay there. And then you drive it really hard, and then the bias tracks beautifully. It's still tracking beautifully. This thing takes a while to get the heat into it. I put all the insulators on there are actually ceramic, believe it or not. You just gotta be very careful tightening those down, the ceramic ones. I'll throw pictures up on the screen there again. And yeah. But this thing works very well. As you can see, it's nice and clean now. Nice LEDs in there. Power switch just wore off, but I might add a little bit of paint or something on there to blacken it out. But originally this whole thing was shifted over. This entire volume control was actually up against the front faceplate, and it was actually rubbing. Now it's nice and smooth. Everything's nice and lined up. The chassis was, like I said, this thing was dropped, which is got a lot of glare on there, but it's normal. Light up top too. Like I said, this thing was dropped. It caused quite a substantial amount of damage, especially to the chassis and the frame. But everything so far seems good. I straightened it out the best I could. Painted it all up, sanded it all up. Got rid of it. Anything exterior wise, like the back of the amplifier faceplate in the back, it never got painted. It just got masked off. And then the inside of the panel got painted, and all the other chassis parts, brackets, transformer brackets. Let's have a look down in here. As you can see, it's all painted all the way around. Whole chassis, this thing came right apart. You'll see that. You'll see that in the video. But so far, like the original filter caps, they checked out good. They were actually at capacity, and there's only just sitting and idle less than 50 millivolts of ripple on the AC power supply, or the plus and minus 61 volts on both sides. The grounds of this unit are all tied together. Even both power supplies are all tied together to the point at the back, which is normal. That's just the way this thing goes. I thought maybe they were separate itself, but the schematics, everything does go back to one point, which is, you know, kind of a star ground kind of thing, but which is good. It's got the JRC 4558s down there for the dual servo controls. It uses 1 op amp per side, one for the positive feedback and one for a negative feedback, and it controls it that way for the DC offset. And this thing has good. It does a beautiful job at that, doing the offset stuff like that. A lot of the current transistors up here, any of the 2SC 1815s got replaced, and the KAC 1845s and the 992s. The MOSFETs, they're original. They're kind of harder to find. Same with the driver transistors. They did come in with a good gain. To try to replace those driver transistors to get the same wattage dissipation. I can get voltage and current, like the MJE 340s, I think they are, or whatever, the 340s, the 350s. They're somewhat kind of adequate, but they're not. The problem is getting the correct power dissipation. You can get voltage and current, but the power dissipation on those things are hard to find. But they do work, and they seem to work very well. The boards have been, defluxed, and all the solder joints have been completely redone. Yeah, a lot of work. I put those down here. They're 620 ohms. They were 1 watts. I put them to 620 ohm, 2 watts. And it's nice about the new components because they're 2 watts, and the 1 watts are, they're pretty much the same size now. So everything looks the same. And twice the dissipation, which they run much cooler now and a lot more accurate. Exactly 18 volts, well, 17.8, 17.9 volts plus minus on the op amps. So they're bang on with voltage references. And it's from the regulation circuit down here, which, like I said, I replaced them all, some Zehners, and same with all the voltage references for the diodes back here, Zener diodes, capacitors, all that stuff's got redone. Back in this section here, kind of mind the light, but yeah, so everything's been really good. I got the P3060 here, preamp. I got to recap it now, and then once I get it finished up, I'll bring them both back in, and then I'll hook them up to my JVC SK404s, and we'll do a sound test on this thing. Before I give it back to the gentleman. I think you should be very happy with this. It seems to run very well, sounds very good. So if all else doesn't fail, I'll bring you back into the next part.